let's start. So, as we discussed last time, we will be discussing about Cassandra system design, or maybe a deep dive, whatever you can call it. And I just gathered whatever possible from all over the place. And most of it is from the same book, what we were referring earlier. And I'll just be discussing most of the stuff from based on my information gathered around everywhere. Okay, so the Cassandra, actually what we discussed last time about Dynamo, and Cassandra's design is almost like Dynamo, but there are certain differences for sure, and they are not very small differences though. That is what I found. And there are some major changes in the architecture, and maybe they are more efficient, and that is what they thought it is good for Cassandra, because Cassandra, they talk about it's a wide column NoSQL database, while Dynamo was more of a key value store, right? So regarding to this requirement, it might be slightly different. Okay, so to start with, it is a distributed and a scalable system, because it is distributed nature. All of the data is distributed across different nodes, same like Dynamo. And because of its distributed nature, you can scale the system well. And secondly, it stores huge amount of structured data, wherein Dynamo, it was more of a key value store. And here, it is indexed by a row key. I think that also we were doing the primary key indexing, right? And the only difference is you have unbounded number of columns over here. So if for a particular row, you can have different columns. So that is something different about Cassandra. And that is why it's called as a wide column NoSQL database. And yeah, whenever you call it NoSQL, it means we don't have any joins, we don't have any foreign keys, we don't have any relationships. So all those things are not there. So that is good to some extent, but there might be different challenges, okay? And therefore, the way it has to be used and what are the requirements are totally different than the relational databases. That is what they are trying to be very clear about, okay? And so what, just a general background, it combines the distributed nature of a Dynamo and also the data model of Google's big table. I am not aware of what is the data model of Google's big table, but it should be similar, something like column-based data store. And maybe when we come to that point, we'll discuss about it also later. And so this, I think, was Cassandra, was developed by Facebook for their some inbox search facility feature or something like that. And then it was given to open source, and now it is an open source project, right? And as we discussed last time, Dynamo was an AP as per the CAP theorem, which means high availability and partition tolerant. The same thing remains here also. So it is more about the availability, high availability for the write request. But there are some changes, or maybe more importance is given to consistency also. Because in Dynamo, it was more of a eventual consistency, and it was always high available for writes, and there was no compromise in it. But here what they say is your consistency level can be tunable. You can tune it, but yeah, when you tune a consistency level, so it means you will have a performance, you'll have an impact on the availability side, right? So that is what the trade, what you have to consider for. So now the very basic nature of Dynamo as well as Cassandra is a decentralized architecture, means we don't have any leader. So everything is leaderless. So all nodes work on their own, they are independent. But yeah, the data is shared. So because of this decentralized architecture, you don't have a single point of failure in a cluster. And so the performance can scale linearly, because you can keep on adding more nodes and then they get adjusted in that leaderless architecture. And as I said, the nodes can perform all the DB operations. So any node can perform any request and handle any request from a client.
I have one question here.
Sure.
Yeah. So when last time I spoke about Dynamo, right? We spoke about like all nodes are same, but the thing is there's one special nodes will be there, right? For the coordination thing. The same applies here also in
Yeah, see, that
Cassandra?
is what I'm saying, even if the Dynamo and Cassandra architecture is similar, but it is not very same. Yeah. So they have a coordinator node also, but it's slightly different than in the Dynamo. So in Dynamo, we had that hash ring, and so first node which came in that hash ring range was considered to be a coordinator node and proceeding with its replicas. But here, the coordinator node is slightly different. So whichever node receives a client request will be a coordinator node.
Not the coordinator one. So there is one special name I forgot actually. So all nodes are not same, right? In Dynamo. So they say all are same, but there is some special nodes.
Node. I think you're talking about seed node.
What is that?
Seed node?
Yeah, seed node. Yeah, the same thing applies here also.
No, they have not talked about it. Maybe it might be there because some of the things they are not discussing, like even about resolving conflicts. So maybe they are assuming the same thing applies over here. Yeah, sorry, go ahead.
So actually in gossip, right, when gossip come into picture, the seed node is required, right? So in Cassandra also your gossip protocol is installed in all the nodes, right? So seed node also here available.
Yeah.
In Cassandra also.
So seed node is more for the gossip, yeah.
And it generally checks which node is faster, like, I mean, who is accepting the right request at faster rate and who is lagging behind. Like, it maintains all the history and data of all the nodes.
Seed node actually is...
No, seed node, that's Snitch, right?
It is kind of...
That's Snitch, that's not seed node.
Snitch is different, yeah. Here you have a Snitch.
No, that's an application which takes control of... Okay, then I think, yeah, that's Snitch then, yeah.
Snitch may be there. Yeah, go ahead, Shreyas.
Seed node is a bootstrapping, means if any other node is went down, it comes up, the seed node responsibility is that update that node, all the activity and other all the activities about other nodes. That is a responsibility of the seed node.
I think
so seed will be for
just to avoid the split brain. That's the purpose of seed node. So they should not be, the logical.
No, this is leaderless. This is leaderless architecture. So why split brain? Split brain happens in multi.
It could happen, right? If there are say 10 nodes, and 5 nodes make one cluster, and another 5 think they are the one who are connected. So split brain can happen any time. In leader, it doesn't happen, but in leaderless, it can always happen. Right.
Okay. I mean, I had an impression
so
that
that's the purpose of seed nodes. Seed nodes is not directly related to gossip. It's just a tool which can avoid this split brain, avoiding creating multiple logical cluster within one cluster.
So that's
because of split node, it will be used to initiate communication with all the nodes. Okay. That's why it is not to create a split brain. Okay. So it is consider all the cluster as single cluster.
Exactly. So
it's like internode, right? It's like internode, decentralized system. One cluster will have multiple nodes.
And this node, seed node, is configurable at a boot up time of the system. When node is boot up, it is configured. This is your seed node. And seed node can be multiple. This is not one single node to avoid single point of failure.
Okay. Yeah, so I'm not sure about split brain because we have not discussed over here. But we can actually get back to that later. Okay, but yeah.
So Joking has talked about seed node, Santosh, in Gossiper chapter.
It was only for gossip. Yeah, so that is what I would say. Because here they are talking more about that snitch, and whenever we want to find the fastest node, so that is the functionality of a snitch. But I think the seed node still might be in the underlying of that gossip. because you still need a peer-to-peer communication between all the nodes, right? So to understand the state of each and every node and whatever is the range, what they are actually working on. So maybe.
So basically, seed node is the intersection of two clusters, right? I mean, acting as a bridge between these two clusters. Is it what I got right?
Seed node is like a bootstrap node.
Yeah, bootstrap node.
So you have, say, a set of seed nodes which you can rely, and those nodes are your starting point to get the cluster information. So just think about it. If seed node is not,
you can assume that somebody new hire joining your team, and you are mentoring. You are passing you are mentoring. You are seed, okay. You are mentoring to that person. You are passing all the information about the team. Okay, that guy he taken all the information from you. Know about the peers. That is equivalent like that. You are the seed. You are passing information to the new joiner like that.
Yeah. So whenever a new node is actually put into the cluster ring, right? Yeah. Go ahead.
Yeah. I mean, how that seed node will know that the new node has been added. So
yeah, actually seed node it is configurable when your node is joined to the cluster, right? So we configured through management that this is your seed node.
I think no, I don't think that's how it works. Seed node is something. Just think about seed node is the node where each node has to contact with them. So when your node is coming up, they know, okay, this is the guy or this is a set of guys we have to reach. Now those guys, when you're reaching them, there's no way like you can form a different cluster. So that is your starting point. And those seed nodes have all the information about the existing cluster. So say you have, say, 10 seed nodes, and out of 10, like 8 are available, but they still have the full cluster information. If there is no seed node, then you might end up joining some node which doesn't know about the actual cluster.
Okay, so that means
they will create different.
When the server is up, node is up, so it has all the information about what are the seed nodes available on that cluster.
Yes.
Got it.
So seed node, they have about information about the seed node. The seed node don't reach to them. The instead node are reaching to the seed node, asking about the cluster information.
Yeah, clear.
Right. To start with, somewhere we have to start, right? Whenever a node joins in a ring, so it has to have some information, and that is what seed node helps those new joinees. Yeah, perfect. That is right. But so I was always,
and there can be multiple seed nodes, is it?
Yeah, that is what it is. Because again, we have to avoid SPOF, right?
Yeah,
right.
So for that, you will surely have. But I think Dynamo discuss only of 2. But yeah, people say they are more than 2, 8, 10. Yeah, maybe, because if it's a big cluster, because you are actually Cassandra is multi-data center also, right? So you might have more rings also in the same data center and all that stuff. So it might be more cool.
So apart from gossip, where did you guys hear this word seed node?
I heard only in the gossip.
Okay, thank you.
Yeah. For now, I just heard it only.
Peer-to-peer network, that is the common concept.
Okay, thank you.
Yeah, but
like BitTorrent and others.
I myself don't know if Cassandra has seed node concept, but Dynamo definitely has. I have read about it. So Cassandra, I think we can go and search, find like if their seed node exists or not.
Okay, thank you. Yeah, I'll go back and check Dynamo for gossip and seeding. Thank you.
Yeah, maybe next time when we will again discuss more about that.
Yeah, I think in Cassandra also they have it, because data stack website set has this seed node thing.
Right. Yeah. Somewhere you have to have that, right? Yeah. Yeah. So now again, because of the decentralized nature, each and every node has to communicate with each and every node to understand their status, whether it is up or down. How do we communicate that, and also keeping the information of the range of keys what a node is handling. So that is what we have a peer-to-peer architecture, or maybe what we discussed just now about the gossip. Okay. And now in Cassandra, consistency by default is configured for eventual, but they talk about tunable consistency level with different replication factors. So that is very important. And that was not a part of Dynamo. I think Dynamo was more static in terms of consistency, but I may be wrong. And here the tunable consistency is given more stress, and we'll look about all the details about what different consistency levels we have in here. Now, before going in that, so what is actually the data structure, basic data structure, what they are discussing about Cassandra, and it's slightly different. So it is said that it is classified more about a column based and database, right? So it is more column centric, and therefore the basic data structure will store a set of columns which will have a column key and column value, and then you will have a row which is identified as a unique key. So for per row you can have a combination of row, column key and column values the way they are. There might be more number of column keys and column values like this. And you can imagine this to be something like a sorted map, a map of map. So this is what I read somewhere. So it is like you have a map, and this sorted map, the first key will be your row key, and inside you will have this nested map, sorted map, which will have column keys and column values, which will keep going like that. So if we just imagine it is this way, so the map gives a more efficient way to look up a key, and because of the sorted nature, actually it gives efficient scans, and you can handle range queries and all that stuff. So the number of columns are also bounded, and therefore this nested map makes more sense here. But it's not the way it is, but it's just an analogy how it might be in Cassandra. So that is one thing. And then all these rows, whatever we discuss here, they are actually a part of a container. Okay. So table, right? So that is what a table is, a container of rows. That is what it says here. And a key space is a container of tables. So this is what it talks about. So I'm not sure whether they really call tables in Cassandra. I think somewhere I read it's more of column families, but here it is said like a table is a container of rows, and the key space is like a database in a relational terms, and is a container of all tables. And then you have clusters, which are container of key spaces. Okay.
So do we have any advantage of this wide column? I mean, storing the data in this fashion? Is it like compaction and all can be performed here, or like if for certain column value we have null, we can completely eliminate that column?
Yeah, so I think Cassandra doesn't store any null values, right? So that is what they say.
Yeah, so that way.
So that's what it reduces. And while coming to this column advantage, so if you look at the map way, that is one thing, because for a particular key, you can have a flexible number of key and values, right? So you don't want, in some cases, you just have 2 keys, and some cases you have more than 2 keys, right? So that flexibility is provided here, over here, and or having that flexibility, it can be accessed just with the row key or the primary key, and the access is also very fast, in spite of having a flexible nature of this data structure. So that is, so whatever the applications actually have this advantage or want to use this as an advantage, so for them it is good. So I think they talk about some use cases also, which is about the time series database, and then maybe something to do with the streaming databases and all that stuff, right? Yeah, but I'm not very clear. If someone has more information and puts on that, please, I mean, yeah.
Somebody mentioned about compaction, right? I mean, I don't want to digress from the main topic here, but probably you're referring to column databases, not wide column databases. In column databases, you don't have to store null, or you can do compaction and those kind of things. And second question is, you mentioned this sorted map, right? When you say sorted map, is that some Java term?
Well, it is just a generic term. I just got it from somewhere. Yeah. So okay. You can think about a Java term. Yeah. sorted map, a tree map, something like that.
Or tree
So
map,
normal
not a
map
hash
also,
map, right?
hash map
hash
also
map.
you can use. Hash map you can sort it in other languages.
Yeah, but they are saying in some cases you need sorting of row keys also.
So we are
or
talking
range
about
keys.
some kind of red-black tree, right?
Yeah, something like that. Yeah.
Okay, thank you.
Yeah, basically, Cassandra store as SS table. So it's append only. So if, and the compaction is the mechanism where it compacts those sorted string tables. So as I mentioned, it's append only. So the beauty of Cassandra is faster write. So you can write at a very fast speed. It doesn't go back and do kind of, random lookup and then update the data. It doesn't do those things. It just append it to SS table.
Oh, you were talking about that compaction, is it? I was thinking of some other compaction.
Yeah, I was thinking
for
of
me, compaction means if you have like 1,000 rows and only one of them has a valid entry in one of the columns, you just have to store that column's value, not the rest.
Yeah, so that is by default. Cassandra doesn't store the null values. But so when we say compaction, what I understand from the compaction in terms of Cassandra is the SS table compaction.
Yeah, when you are writing a write request, right? A key.
Yeah. So after some time, it compacts those SS table and form new SS table. Like it's just like any log-based compaction you have seen, like in Kafka and other stuff. Same thing here.
So even mem table will be sorted because it takes data from.
So mem table is already sorted, but there's no compaction required there, right? It's in memory. So when it has to fetch, then there are strategies like where it should look the data. It looks into a mem table, it looks into SS table, and then it aggregate it. But MM table is already hashed key, I think, map based.
To be fair, it's hard to understand this concept like mem table and SS table because it's not yet covered, right, here. I mean, I find it difficult to know what you guys are referring to.
Yeah. So one more thing, someone discussed about wide column database and the column database. So can you just give an idea of what actually the difference are between both of them? Anyone has any?
So in column database, it's mostly step where you can do all the aggregations.
For analysis,
the way
OLAP kind of thing.
Sorry, OLAP. So basically the way the data stored on disk is different when compared to imagine this way. So on a block in a disk, all the related column values are like stored in that specific block. This is what happens in columnar database. Whereas row, you store an entire row, you store an entire a set of rows in the disk block. So that's why when you store all the columns in one disk block, then you can do all the aggregations or encoding. It's pretty effective for this for those use cases.
So you are saying if you store a block of columns in a set of columns in a block, that becomes a column database.
No, that's a row.
That's right.
Let me add a couple of words. Just imagine that we have a table and 100 columns, yeah? 100 columns. In column-oriented database, we basically will have 100 files. And each files, we will keep all columns, all values of particular column in particular file. One file per column. But in row-oriented, we will have just one file. Yeah.
So one file in the row variant will have all the columns of that particular row.
Yeah. So in column-oriented, one file.
Yes. In row oriented, you have like set of rows, just like you see in the table where it's all like set of records, right? Set of row records. So that is how it is stored on row. That's why you can like if you look at the queries, you generally when in row-based in row-oriented databases, the queries are like you always fetch a row, right? You don't you're not interested in like in particular column. It's always row-based. So disk has this set of rows, and then you can always get a specific row by its key, or you can get a set of rows in a sorted manner in case of paginations. But if you take the column column store where you do some kind of aggregations, right? Like, okay, get me all the like average salaries of all employees. So the way the data stored is like for the specific salary column, all the salary values are like stored in that specific block. So that and the database actually reads the data in terms of blocks. The buffer manager will load those blocks, and then it can with just one IO, it can load all the values and then compute it, rather than fetching each row and then going to that specific column and getting the value.
Yeah, just to add to what he's saying, if you're doing an average of something and your database size is 1 gig, in row column database, you'll have to you'll have to load all the 1 GB from the hard disk. But if it is a columnar database and your column is contained in only 10 MB of the data, you will have to get only 10 MB from the hard disk.
So main idea is avoid the disk seek. If it is row based, you have to go to multiple blocks to read that
That's
data.
right. That's
not
right.
the size. That's probably right. If you are doing projection, you might get the same size. But the main idea is for column based database, you have to just read one or few blocks which are together, sequential read. So you don't have to teach your disk head from row to row. But right. Cassandra is not true columnar database, what I read actually.
That's right. That's what we have been talking. So coming back to that question, where this database is used, I mean, so it's clear that columnar database is something else, and that's used for OLAP query. I think Cassandra is more for like document database. Maybe like its competitor would be JSON, MongoDB, I would say.
Okay. Yep. Thanks for actually giving those inputs. Yeah. Yeah.
Yes, there is one interesting fact about Dynamo and Cassandra. Yeah, when we were talking about Dynamo, we was not able to change some small part of object of value. Yeah. But in case of Cassandra, yes, even we, let's say that we added 10 columns, yeah, for particular row and save it to disk, save it to Cassandra, yeah. So Cassandra created SS table, yeah, and after 1 hour, let's say that after 1 hour, we inserted one more column for the same key, yeah. And during the merge process, during the merge of SS table, Cassandra will merge, will add one more column to the row. Yeah.
Okay.
Yeah.
So that is the flexibility what Cassandra has.
Yeah, the updates are immutable, so that's why we maintain a mem table where it's only the mem table is like a single large file with multiple segments. So every update is just an append to that segment file, and at some point in time there's a merge process, like compaction and everything. So it only picks up the latest value and then flushes it to the disk.
Makes sense. Yeah. Cool. Yeah.
Should we let Santosh maybe speak for another 10-15 minutes before we take more questions?
Yeah, no problem. So that was good actually. So therefore, Cassandra is more of a wide column data structure, right? Yeah. Database, sorry. Yeah. So this is the way it is. Okay. Now, so about the Cassandra keys, okay, and I think we discussed this. So Cassandra keys actually they say about it is made of two combinations. The primary key has a partition key and the clustering key. So the partition key actually decides how data will be stored across the nodes, and that is more for the partitioner. Now, if you look at the data partitioning here, and the way data is stored in Cassandra, it is actually again a ring-based storage, what we did look in the Dynamo. So if you see in this diagram, I've just drawn some servers. I think there are almost 11 servers, 1, 2, 3, 4, some of them are missing the fine. And so whenever we get a key, that key is actually taken, the mapping of that key is done by a partitioner over here. That is what they call that terminology here. The partitioner actually does a hashing of that key, and based on the hash value, it will assign that particular key to some of the replicas. So in case if we had some key like key 004, and that key was actually hashed between the range S11 and S1, so the key will be stored on S1, and along based on the replication factor. In this case, I'm assuming the replication factor, we have 3, like therefore the key will be stored also in S2 and S3. So the replication factor is nothing but how many number of replicas at a time is the same key has to be stored. So that is what the consistent hashing ring will do. And so that is what they are discussing over here. It is similar to what we discussed in Dynamo, and it will also have the V nodes and everything stuff, but that's not actually shown in detail over to hide all the details, because we already discussed that. And here we have one ring per data center. So there might be Cassandra actually has about storing all these rings in different data centers also, and they coordinate with each other, and that we will see when we go for the consistency level. And that is why actually it is more stable, I would say, than Dynamo, because it has to do much storage of used data, right? And it has to across different zones and everything. So therefore it stores in different data centers also, and then there is some coordination between different data centers for some of the replicas. So we'll see that later. But yeah, whenever, if we just consider per data center now, whenever we get a client request, so any node which accepts the client request, because in consistency hashing we can have any node accepting any client request. But in Dynamo, what it used to do is because each and every node has information of all others. So it will just forward it to that particular coordinated node based on the range of that key's hash value, right? But in this case, it doesn't do that, because each and every node does have the information. So here, the coordinator node itself is the node which a client request lands on. So that itself is a coordinator node. And so it will actually know where this particular key lies to, and it will just forward that to those respective replicas. So in this case, if this key 004 was mapped to S1, and it had replica S2 and S3 also, which were the backpacker replicas, it will immediately fire and send this request to all of the 3, and then it will be taken care by the replicas. So it will be a happy situation when there is no network partition and all that. Okay, so when network partition happens, and we'll discuss that later also. So what will happen is one of the replica is down. So then the way it is done is using a hinted handoff. So the hinted handoff here in this, in Cassandra, it is said like the coordinator node does. So it stores the data in a text file, they call it. And then this text file will store the data for some time. Whenever the node comes back, then it will actually send that data back from the coordinator node to that particular node, which was the right replica. And so when you are doing this hinted handoff, so it might so happen that also because anyone can act as a coordinator node, and also anytime any of the nodes can go down. So the data on the coordinator node for this hinted handoff also can grow, right? And also it keeps that data for some time, and they talk about like some hours worth of data. And after that, it is overwritten, because we don't want to keep more data in it. And what happens to the previous data, and in that case, will it be inconsistent state? I'm not sure, because that is what they discuss about it. And those things will come later. But in a brief, it was about the constant hashing and the ring and how things are taken care of here. So now the major thing about this Cassandra is the consistency level, right? So the consistency level, there are actually, first of all, if you look at the replication factor, we know what replication factor is. It's nothing but the number of replicas which a key will be replicated, okay, or maybe the data will be replicated. And that is the only thing. But generally, it was a replication factor was 3. So if it is a 3, then every time any request comes in, it will be stored on 3 replicas. That is what the replication factor is. But here, the more important is about the replication strategy. So the replication strategy says that we have 2 types of replication strategies here. One is the simple replication strategy, and second is the network topology strategy. So simple strategy is the same what we discussed in Dynamo. It is a hash based. Whenever you get a key, it is hashed and then stored in the particular range or the token. Based on that, it is stored. But there is one more in the simple called as range based also, and it is I think it's called as byte ordering. So whenever we get a key, so all these ranges, instead of dividing by the hash, they are actually divided by the range of the key values. So the key values are not actually hashed, but based on that they are stored, and it is easier for range queries. So that is one more option in the simple strategy. That was one thing what I came across. And the second, the network topology strategy, that is more important over here, because in the simple one, we were only focused on a single data center, but here it can be, this strategy actually takes care of multi data centers. And also the multi data center, each and every data center will have a different replication factor for every data center. So that is a flexibility in Cassandra. So network topology, it can be like you can specify 2 replicas per data center, or maybe 3 replicas per data center, and each replicas, like 2 replicas per data center. Each replica will have each data center will have 2 replicas based on the distribution of your data. And every time, one more thing what was discussed is like if you consider in a data center, and if you want to honor this 2 replica, so the first replica is done by the partitioner. So partitioner is nothing but the one who actually does the hashing of a particular key, and then it assigns a particular node. So that partitioner first will assign it to a particular replica, but then it will keep on going. It will go clockwise to find another node for the second replica. But in this case, it won't stop until it finds a node which is in a different rack. So the reason is like, if to avoid fault tolerant, to make it more fault tolerant for a rack failure. So that is one thing which is taken care in the network topology. Okay, so
just a quick question here.
Yeah, please.
Is partitioner a separate node here, or I don't know, what is this? Just a hash function? What is partitioner exactly?
Partitioner,
hash function.
It is a hash function. It is like a component they talk about. So it might be a separate component altogether, or maybe a separate service.
No, it's the hash function.
It's just a
hash function. It's murmur hash, I guess.
Maybe it's a library function then.
Yeah, just a hash.
So every node knows about this hash function, and then every node can basically does this partitioning. That's what.
Yeah, it's just a hash function, and then it will look up the range, which node contains the range, which has this value within that range.
And do you guys read about what hashing strategies these guys use, Cassandra?
By default, it is murmur 3 partitioner.
Murmur 3, yeah.
Oh, really? But Dynamo was using different one, no? SHA-256.
MDA, what is that? SHA, yeah.
No, SHA-256, yeah. So Murmur 3 is much better. And
no, Murmur 3 they are using, but here they can use other thing also. SHA also they can use, MD5 also they can use. But once the hashing is got selected, you cannot change it in between.
Right, but what is the reason of Murmur 3, and what is different?
Yeah, I think it's pretty efficient when compared to other ones.
Okay.
Pretty efficient in what sense?
In collisions, spreading data spread distribution.
Sure. Because I think performance of Cassandra is very, very good. And there are some numbers also when it's compared with other databases. So I thought maybe this particular hashing strategy, what they're using is very important, plays a very key role in that, because that is what gives more low latency, right?
No, I don't think so. It's just a hash
No,
function.
it's for data distribution, data load distribution.
Yeah, but the data distribution will always come from a hashing function, isn't it? So the way it is efficiently hashed, so it will be distributed. Yeah, I know it's not a very easy thing, but eventually everything has to be run in very synchronous way.
Yeah, you may have a point there.
Yeah. Yeah, no problem. So, okay, now.
Okay, one more point. When they're saying that they want to basically, put the data in a different rack here in the last line. Does this mean that in network topology, we need to have replication factor, the number of racks should be more than replication factor maybe, or right?
Okay, so I think the ring is distributed across racks. That is what it's trying to say. So, but it doesn't say that, it doesn't stop us to do that. So you can have in a single rack, you can have a ring, but you can have a ring distributed across racks also. And that is what the network topology talks about.
What is this? Yeah, the basic idea is make it more fault tolerant. So you can store replicas in the same node, or even between like different nodes which are present on the different racks. Even better when you do it across across availability zones. It just to make sure that the fault tolerance, you're making more fault tolerant.
Yep. So that is
what happens if my replication factor is more than number of racks, and if I am going to choose that it should use separate racks, then how will it replicate?
It is not always that. But it is always good to have at least one node out of the rack.
Okay, sure.
Outside of the rack,
yeah. So therefore, after the first replica, if you have a second replica out of the rack, then the others you can actually find wherever you can place them. Shashank, you had something?
No, I was confused about rack, but I got it.
Okay.
This rack term.
Yeah.
Somebody said murmur 3 is fast. Right? I just checked. Yeah, he was right, because it's 3 to 5 times faster than MD5.
Really? Oh, okay. So the efficiency, the performance is more better.
Because MD5 is kind of cryptographic hash, and that takes time.
Makes sense. Yeah. Okay. So now here, when we are talking about also the consistency levels, and that is very important in Cassandra, even though it's very normal topic for most of us. So what it is, because the consistency level is very configurable, and it is configurable, tunable. So, okay, what it talks about, minimum number of nodes that fulfill a read or write operation. So that is what the consistency level will be based on the replication factor and all that. And it allows different levels for read and write. Okay. So there is one table which I got from somewhere, and it talks about, these are the consistency levels. And also the consistency level is specified per query by the client. So the client specifies a consistency level, and it can be different for different queries. I'm not sure that is the right, but I think it might be. But okay, so whatever it is. So here are some of the configured levels, which starts from the consistency level from the very least to the very highest. So any will be like for the write, and the read what actually any means. And so even if one node is there, so then the write will be accepted, but there is no thing for a read in that case. And 1, 2, and 3, maybe if there are 3 nodes, right? 1, 2, or 3 nodes as a replication factor. So you will have a write request, you will have to fulfill or have to be written to 1 or 2 or 3 replicas. And for the read, it might be you'll have to return most recent data from the closest of with the 1, 2, or 3 replicas. So whenever you actually read from the replicas, like in case if it is a 3 configured replicas, so you'll have to read from all the 3, and whichever is the most recent data, you will actually send that to the client. And
so
then it,
I mean, closest is like what? In clockwise, when you move, whosoever comes nearer.
Well, I think closest will be based on the response closest, or maybe based on the data center, you know.
Or so the one who is having the fresh data, I mean, updated one, right?
Yeah, so most recent data will be like that, but closest will be from the very closest data center. That is what I assume.
Yeah, both are right in a way. So it's not only in the data center, but also like you also move clockwise. Because it's a consistent hash string, right?
Okay. So whichever is the first one you take from there. Okay, makes sense. And then you'll have a quorum. So quorum, we all know that if the quorum has a replication factor, something like that. So if you divide that by 2 plus 1, based on that, whatever the nodes you get, so that will be a quorum. So for if the replication factor was 3, in that case, you will have at least 2 replicas where you will have to write data till you send an ACK saying, okay, you have written successfully, right? So that is a quorum for write. And for the read, actually, you will do the same thing. You will get all the most recent data and from the closest quorum replica. And in this case, you will do a read repair also, right? And everywhere you will be doing a read repair wherever possible. And then this is the quorum what we know about. It's more of a strict quorum what we used to discuss, right? But in Dynamo, we use a sloppy quorum. But yeah, but here it is, everything is divided very structured way. And maybe the sloppy quorum is not a good term, you know, because we have all of these as configured, and you can use this levels to configure per query request, right? So therefore it might be more flexible and it's more powerful. That is what I look at it. And now in the same thing, you can have a local quorum. So local quorum is nothing but it's for that local data center. Same thing for the read also, it will go to the local data center and you'll find the same based on the quorum. And each in the sense means it ensures that it goes to each and every quorum on each and every data center for writing. So it will satisfy all the quorums for all the data center. And for the read also, it will do the same thing. And so for all, it means you have to write to all replicas. And then for the read means you'll have to read from all the replicas. So if you look at
it on each, initially you mentioned like the ring is found within the one data center. So now how this each will work? Are we going to have 2 different rings, or is just one ring across?
No, you will have, every data center will have a different ring. So yeah, every data center will have a different ring. And so each means you will have to go to each and every data center's ring, the consistency ring, and then you will have to write per the quorum.
Okay. And one question, not sure if it's much relevant, like on the client side, do client need to aware of both the data centers, so they always connects to one data center and everything gets automatically discoverable?
I think it should, right? So when it comes to any ring, okay, so if any node is accepting a client request, so even if it does it for its own data center, it is aware of other data centers rings also, because if it is going to do each and all these quorums.
Yep.
So that has to be there.
Okay.
So
my question is like some of the like for example in Couchbase, you can have multiple clusters across different data centers, and then it use I think XDCR for replicating the data, but client has to connect separately. They have to take care of failover manually. Same thing is, I think, with the Kafka. Kafka also, you can have cluster across different data centers, but client has to take care of the failovers. So the same question in Cassandra. I don't know, like I never worked on Cassandra.
Kafka actually, are they using leaderless? Don't think so, right? They are.
No,
really...
they have leader. So for fault tolerance, you have one active cluster, another one. Like it's just like what you are doing is you are providing reliability from the data perspective, but user has to connect separately. For different, there are many other reasons, like you don't want to process the same event twice. So that's the thing. Like so that is more sort of fault tolerance. But here in Cassandra, question is like from the client perspective, it is transparent. Like, do they need to be aware of the clusters? If anybody is aware of that.
Actually, I don't think so. It is required because you just send a request to particular node, and that node should take care of it. But internally, what happens is, even if we are saying each and every data center, there is a coordination between each and every data center's rings. So they actually, somewhere I came across, it's like they are using, for coordinating all these data center rings, they are using some coordinating service also. Okay, so though even being a leaderless, at least for those things, at least for having the information of other rings, so that is done through some coordinating service. That is what I think.
Zookeeper kind of.
Right.
And this quorum is across the DCs, right? And locally is within the DC, right?
Quorum actually, quorum will be for a particular DC per DC. And then it will be, when it is each, then the quorum will be for each and every. So each and every data center will have a different replication factor. So the quorum will also be different. Isn't it?
So what I had, like quorum can, quorum will be like some from this DC, some from that DC, and if they satisfy that equation, then.
Yeah, I also had same thing. Quorum also you maintain multiple DC.
And in local, it will go inside one DC.
Yeah.
Right.
To avoid failure, power failure, or
power failure,
right? Something like that.
Wouldn't read be costly in those cases if we are reading from multiple data centers also?
Yeah.
But availability will be more, right? Read is costly. Let's agree.
Correct. Yeah.
But availability will be there, always available.
So read will be more available, but write will be, it will take a hit on availability. Read availability, right? Write availability, sorry, yeah.
It again depends how many nodes you assign for what, right?
Yeah. But consistency will be very strong in this case if it's all, isn't it?
And
yeah.
Regarding any consistency level, it doesn't guarantee durability, right? Because it's just writing to the coordinator node, and then that can die off, right?
Yeah, that also can die off. So they usually say don't go with any, and that is what is discouraged most of the time.
All will have lot of latency, right? Every node has to confirm that he has written the data. If the coordinator.
That's a very ideal situation. Like if you want to actually store very durable and it's very important data. So, but that is what they are saying. You have all these flexibility inbuilt in Cassandra, and therefore it is very powerful. If you want to use it for a particular request, it is required. It's very important data. Then why not store it, right? But for that, you don't have to have a different configuration, reconfigure everything, and again start running it, right? So, but you can do it on the fly. That is what they're trying to say.
Because even if one node doesn't send acknowledgement, then that write is invalid, right?
Right.
I guess best thing is you can specify the consistency level per request. So you can decide how important this data is for you and decide consistency level you want. So, yeah.
Exactly. Yeah.
Per request means you are meant to per write and read request also you can maintain something like that?
Yeah. That is what they say.
Okay.
Yeah. Yeah, it is. So, but most of the time it will be like 1, 2, 3. But in some cases you can have all very important data. or something like that, which you have to store for long. Yeah. So now, okay, I didn't cover more about Snitch. We can actually discuss that later, you know. So now we know about this hinted handoff, right? So the hinted handoff, as I discussed, what will happen is whenever a node goes down, it will be written as in a text file in a local disk. And also, so whenever a node comes up, and that particular node will know based on the gossip protocol, then it will actually return all the data to that the respective node, whichever is responsible for the data. And in that case, then only thing what will happen is if the node takes a longer time to come back, so there might be many coordinator nodes which are accumulating data for that particular node, isn't it? So whenever that node comes up, there will be many of the nodes start actually communicating with that node. So that might be a network overburden. And for that, they are saying that this particular hinted hand of whatever that data file, which is stored locally in the coordinator, will have a restriction of storage time. It talks about couple of hours. And this couple of hours is necessary because you don't store more of data in it. But then what happens after, if we configure it for 2 hours, so of all the data before 2 hours, even if the node doesn't come up within 2 hours, I think it's reasonable for a node to come up within 2 hours. But even if it doesn't come up for some reason, so that previous data will be overwritten. Okay, so it won't have that previous data. And so in this case, I think there will be an inconsistency in data. And I'm not sure how it is handled, and this has not been discussed anywhere. But this makes more sense because whenever a node is coming up, we don't want to overburden with a lot of requests to that particular node to get it up to the speed, right? So, but they are handling this case, but Cassandra, you might not require it, but there are some chances always of happening that, right? So that is one thing what I saw. And in the read, actually, it does a read repair for every time whenever it is reading. Okay. So this was, and then we'll discuss about Snitch maybe later. Okay. If anyone wants to add anything.
One more question. How does it resolve conflicts across data centers?
Yeah, they have not discussed all that, but then I assume, because see,
generation clock is there, I think, if I recall.
Yeah, like so they still have the timestamp, so
true,
it is stored with that timestamp. So
it's LW.
For every message,
is it right? Because when in Cassandra we don't use that vector clocks, right?
Yeah, last wins. Last right.
We can't really use the actual timestamp, right? We discussed that in Dynamo also, that actual timestamp doesn't really mean anything, that which request has come first. I mean, there can be network latency, which due to which the request which first origin from the client actually reached to the database late, right? So
no, there is not. I think that
timestamp exists. This is an issue even in the write. So
correct.
After writes uses the timestamp to resolve it.
I think they still might be using vector clock. That's what I think, and because the reason why I'm saying is
Cassandra doesn't use vector.
They use the clock time.
They use the clock time, but how are they going to address if there is a network partition?
So the clock time is basically, so I don't think it has to do anything with the partition. It's basically goes back to the clock time, right? Each node has their own way of clocking the time, and there could be some differences. They are not very accurate how the clock works. So some databases have different strategies, but like in Cassandra, they just assume they take that time as the source of truth, and whichever is latest, they will take that one.
But you can't really do that, right? I mean, think about a scenario where
this is what they do. If you need consistency, then you have to use the.
It's not just consistency, right? You are not even storing the latest data. Let's say you have a scenario where you are updating score of some game or something, right? And then two requests left the client at the same time, and then the first request reached late, and then second request reached first, right? Then you'll have the older data present in the database, right? If you just use timestamp.
Then you increase your consistency level in that case.
Yeah, that's what. Yeah, it got rejected, right? If two nodes, it's all the majority wins, right?
That's how you. Very tricky. They are handling it.
Yeah, but Cassandra, as we know, Cassandra uses timestamp. Yeah, it means that we can never achieve strong consistency with Cassandra because of clock drift. Yeah, and in some prod clusters there could be delay, even in which has lag in seconds. Yeah, and
so see, it's all on consistency level. If you, for example, why data can be conflicted? Data can be conflicted because your one node accepted something and then another node accepting something different. But if you're using right consistency level, then you make sure majority, your replication, will have the exact data. There are no chances of conflicting data.
No, let's say that we have a difference between time in 10 seconds. One of machine has 10 seconds in future, yeah? This machine will win, no?
It's only in case of conflict, right? You can play around that, you can do all those hacks. But it is when they see, so there is a conflict data. When, for example, one node saying, okay, X is 10, another saying X is 20. Then you have to do that sort of math. But if you have consistency level, say, for example, two nodes are saying same thing and one is different, then you believe those two nodes. And then you do a read repair on the third one.
I think the recent data is returned to the client, and in the background process, this read repair is happening, like high water mark.
That is the proactive, repair. But if like Dynamo took different approach, it asks client, okay, if there is something that cannot be resolved, then it asks client. But here, what you see is, okay, there is a conflict, then it resolves by the last win, like the last timestamp wins.
Yeah, that's an issue actually. See, that's what even someone has actually just posted a link. The Jepson Cassandra. If you read that, this is actually an issue in the Cassandra. So one way to mitigate this is use a lock where you linearize the writes, concurrent writes, and then that's how you solve it. But otherwise, the old value can be overridden by the LW, last win writes. It's because the time is, it can change. There are, you can read that link. It's actually pretty detailed. Like Nick has posted.
Nick has posted, right? Yeah, I was trying to copy that in the chat. Yeah. Okay. So no problem. So I actually didn't gather more inputs about other stuff. So I was just trying to go through it. So I think we'll stop here for today, and then we'll discuss the later. Maybe on tomorrow is Thursday, right?
Yeah, tomorrow.
Okay, but Friday he's taking that. So tomorrow we might have a database internals, right?
Yeah, I'll have to confirm you. He told that he'll most probably do, but let's see. Yeah.
Okay, so no problem. So I'll also see if something happens, then we'll catch up tomorrow morning.
One question for the next session. Maybe we can also try to see how much throughput or write speed can Cassandra manage maximum.
What are you saying? Just a minute. Let me write it down here.
Throughput means how bandwidth or something like that?
I mean, writes per second. I know Cassandra is good for writes, so I'm trying to think how much writes per second it can handle.
Okay.
I think
Cassandra you want to know about the throughput, write throughput.
It is
and
more
how
for
it is
the
handled.
Yeah, it's actually pretty high when compared to like SQL databases. So everywhere it mentions like it's 10 times more faster. It's just because that write append log, It keeps on appending, and in the background, all this data structures will take care of it.
Yeah, that's true. I think the bottleneck is write ahead log. But then nowadays, write ahead log, it's not the actual disk. It goes to the OS cache. So
you mean the commit log goes to the OS cache?
I mean, every write to the disk always go through the OS cache, right? Not just commit log. First you write to the OS cache, and then there will be an extent or something, and then it will go to the disk.
Yeah, but the OS cache will always maintain the cache coherency as well as
their own file system. So they, for this reason, they don't give control. Like most of the database implement their own file system. They take control over that.
Yeah.
So from what I read about Cassandra, it seems by default, the configuration is every 10 seconds, the write ahead log will be synced from the memory to the actual file. So if the Cassandra node goes down within the 10 seconds, you will lose the data for those 10 seconds. But hopefully, since we have replica, some other replica would have captured it in its write ahead logs cache, OS cache. But anyway, my question was for next session, maybe we can the throughput speed, write per second speed.
So there is hinted handoff, right? You are telling that for 10 seconds.
No, he's talking about particular node now.
Okay.
In particular node when we are storing.
Can you share the article where you studied? Because everywhere I read, it's actually like write to disk. It's only like append, right? It's pretty fast. Like if you take the magnetic disk.
Yeah, usually
but you can read the Cassandra documentation, and that this guy is right that it's around 10 or 12 seconds. So you may lose that.
Really? Okay, that is the way.
Yeah. So even for each write, it does not go and write to the disk immediately. For write ahead log, it put some information in the cache and go in that chunk.
Oh, cool. Okay. Because I thought it's when it is append only. If you take these are like commercial hardware, right? So these are like magnetic disks. So there is no need to like do a seek and then write it, right? So you can write in the place itself, like where the head is. It is.
So you are talking about SSDs?
Every time you get a packet, it will be very inefficient. Every time you get a packet, if Linux decides to write it to the disk, that's not a good thing.
Yeah, see, because it has its own latency there also when it's writing to a disk, because it has to go through many layers. The storage layer is at the very lowest level.
So in general, hard disk would be like maybe
10 milliseconds something for doing the disk seek, and then but the write is like much more less compared to the seeks. In write head, there is no seeks, right?
No, we are not even going to the seek. When Cassandra publishes all their data about writes per second, it's about writing to the OS cache, not the actual disk, because the actual disk would be like, if you take a hard disk, I think it's around 100 MB per second. But I'm sure Cassandra probably says it's much more than that.
Oh yeah, because the disks also are written in blocks. So they wait for some time to get all the data and then they push into a block.
Yeah, do batch writes. Yeah.
Cool. I think that's what I had for today, and then we'll discuss.